Alright, this is unit 0.1, and this is an intro to graphs. Okay. So we have a couple different names, or a few different names to describe graphs. The first one we're going to talk about is the word linear. Linear just represents any graph that does not have a curve to it. It needs to be a straight line. So examples of a linear function would look like this. Just a diagonal line. You could have a function like this. It creates kind of like this V shape. Notice even though it turns around at some point, they're still just two straight lines joined together. Or another version of a linear function would look like this. You could start off as a horizontal line and then end up going up somewhere. So that's linear. Okay. We're going to talk about the difference between continuous versus discrete. Okay. So continuous means that there is no break in the line whatsoever. An example of something that's continuous would be time. We have 1 second, 2 seconds, 3 seconds, 4 seconds, and in between those seconds that I counted, they had half seconds and quarter seconds and eighths of a second and so on and so forth. You can just count time infinitely. There's no jumping to it. It's continuous. So continuous functions do not have to be linear, although they could be. A continuous function would be like this, where you never pick your pen up off the paper. Okay. Or they could also be a linear function. Whereas discrete has certain points. Think of a discrete function as if you were to drive across the country, but you were only to put a point down whenever you stopped at a restaurant. So for example, if you're talking about a line and we go a certain place and we stop here, and we go and we stop here, travel a few more miles and we stop over here, these dots form a line, but these are not continuous. These lines are not connected by something. Okay. It is discrete. Okay. And you can have functions, linear functions just like the one above, or you could have quadratic functions that are discrete as well. Okay. So it's just important to note that discrete dots are not connected, continuous, one continuous drawing, you never pick your pen up. Next we're going to talk about a constant function. Constant functions are functions that don't change in their y values. So for example, a constant function would look like this. The y value does not change whatsoever. I mean, it might look like it from my drawing, but I'm just a bad artist. These are constant functions. So next we're going to talk about increasing versus decreasing. So an increasing function is any function that moves up as we read the graph from left to right. So just like we read books, we read any kind of language, we read from left to right. So an increasing graph will be one that is a line that goes up from left to right. So if I move my pen from left to right along the graph, I notice my pen is going up the paper, which means it is increasing. A decreasing line would be where your pen moves down the paper as you follow the line from left to right. So this is decreasing. Increasing going up, decreasing going down. You can also have functions that change how much they increase by. For example, this function increases and then it keeps increasing but not very steep. Or you could have a decreasing function that just curves and moves straight down. So again, from left to right, your pen's moving up the paper, even though it's not moving as fast up the paper. Whereas for decreasing from left to right, it moves down the paper. So that's increasing versus decreasing. And that's all you need for 0.1.